Hello everyone. I am putting this video together to explain and to introduce to you covalent molecules. Okay. Now, I'm doing this primarily for the people that were out on the retreat and the last couple of days that we've been in class, and we covered some new stuff, and I want to run through that with you now. Okay, for those of you that were in class, you may find this video helpful, just to maybe review the things that we talked about in class. Okay, you will also find online in the student resource folder, I have some class notes there. But anyway, I hope that this video is helpful to you. And after seeing this video, maybe go back to the class notes that are in the student resource folder. You might find some extra insight by doing that. Anyway, so I'm introducing covalent molecules to you now. I want to start with some facts, okay, some background facts that, we've already talked about in class. I want to first talk to you about ions and ionic compounds, and I'm just going to run through this very quickly. All right, so I'm starting with sodium here, and we've got a sodium atom. This is a Bohr diagram, a Bohr model diagram for sodium, and we've got one electron in that valence shell. Remember what a valence shell is, or a valence electron. This is the one valence electron, the one electron in the outer shell for sodium. Okay? Now, we know that sodium is a metal, okay? And metals give up electrons easily. Well, sodium gives up electrons easily. If this atom of sodium gives up this one electron, we end up with an ion of sodium. Okay? The sodium ion has 10 electrons and 11 protons. So that gives the sodium ion a 1+ charge. Okay, I'm going to do the same for chlorine, and we'll talk about it. All right, so I drew a Bohr diagram for chlorine, and in this Bohr diagram, we can see that the outer shell contains 7 electrons, right? Okay, if we were to add 1 electron here, that would create an octet for this chlorine, all right? This is an octet when we add 1 more electron. All right, so I just changed something actually. I moved the word octet over to this ion of chlorine. Okay, this is a chloride ion, all right? So chlorine took on 1 electron in order to obtain an octet in its outer shell, okay? That means that chlorine, this chlorine ion, the chloride ion, is very stable, okay? And now this whole thing has a -1 charge, okay? And by the way, take a look at sodium. The sodium ion is also now got an octet in its outer layer because it lost an electron. Well, maybe you've already, you could already see this, but this electron really is this electron. Sodium loses an electron, okay, and that electron goes to chlorine to form the chloride ion. Now what we have is a positive sodium ion strongly attracted to a negative chloride ion, okay? And what we've created here is an ionic bond. Now, none of what I just told you is new to you. We've already talked about ionic bonds, but I wanted to say it again because we're going to contrast this ionic bond to a new kind of chemical bond that we're now going to introduce. Okay? This new chemical bond is called a covalent bond. You can hear my dog barking. Great. Okay, a covalent bond. Let's contrast a covalent bond with an ionic bond. We'll start with that. An ionic bond happens when you have a positively charged ion and a negatively charged ion close together. They are very strongly attracted to each other. This is, in fact, the ionic bond. Why did those ions form? Okay, here's the key, guys. Listen up. All right, sodium lost an electron completely to create a sodium ion. Chlorine gained an electron completely to form a chloride ion. That gain of an electron or that loss of an electron is hugely different compared to what we're going to see here in a covalent bond. So what is a covalent bond? A covalent bond is a shared pair of electrons. Okay? That's a shared pair of electrons. How is that different from an ionic bond? Okay, an ionic bond was formed when ions either gained an electron or lost an electron. We're not sharing when we're talking about ions, all right? But in a covalent bond, electrons are shared, and they're shared in order to create an octet in the atoms. And to show you what I mean by that, we're going to start with an example. Okay? We're going to start with this compound. This is a fluorine molecule. Okay? This is a covalent molecule. All right? Covalent molecule. I'm going to stress this again. I want you to just really get this. There are no ions in a covalent molecule. You should really be writing these things down. This is going to get confusing for you if you're just kind of listening and watching and you're not really being involved in truly listening, okay? Taking notes is a strategy that gets a strategy of learning that gets your brain truly active. If you're writing these things down, it's going to stick with you better, all right? Make sure that you're taking notes right now. This is a fluorine molecule, all right? There are no ions involved here. So what I'm going to do now is I'm going to draw a Lewis dot structure for fluorine. I'm going to draw two of them, all right? I'm going to do this right now, and I'm going to draw these as I'm drawing them on purpose. I'm going to draw my pair of electrons here, pair of electrons here, pair of electrons here, and one electron left over, okay? I'm going to draw another fluorine molecule. Pair of electrons, pair of electrons, pair of electrons, and here I've got this one last electron in the outer shell. This is what's going to happen, okay? There is going to be these, here, let me just restate that. These two electrons are going to pair up. These electrons are going to be shared by these two atoms of fluorine, okay? Now, I'm going to redraw this in a way that is going to be more consistent with the way that I will draw this in the future, okay? This straight line that I just drew is a covalent bond. That straight line that I just drew is this pair of electrons, okay? And I'm also now going to fill in the other electrons here, okay? All right, that line, and I'm just going to really highlight this, that line there is 2 electrons. So in order for me to count the octet around both of these atoms, we're creating an octet, okay, around each atom, which is going to create a stable atom, okay? Again, I'm showing you this shared pair of electrons in order to create an octet in the atoms. So what are the octets that I'm talking about? I'm circling. There's 1 octet. What do I mean by that? Okay, 2 electrons in this bond. 1, 2, 3, 4, 5, 6, 7, 8. This one atom of fluorine has an octet of electrons. What about this atom of fluorine? Oh, it's also got an octet of electrons around it. 1, 2, 3, 4, 5, 6, 7, 8. All right, we've got an octet around that fluorine. We've got an octet around that fluorine. All right. If we've got octets, guys, we're good. We did it right. Okay? Let's move on. We're going to try another molecule now. All right? So here's a molecule we all know and love. This is water, H2O. All right. Now, I'm going to draw a Lewis dot structure for this molecule of water. Okay? First, I'm going to draw the Lewis dot structure for oxygen. All right? I'm drawing it like this on purpose, okay? We've got 2 lone pair electrons here, okay? And we've got 2 single electrons here, okay? That's 6 valence electrons. All right, I'm going to go in here now, and I'm going to do this in a different color. I'm going to put hydrogen in. Okay, I'm going to put hydrogen in. I want to do this again. There. With 1 electron and another hydrogen with 1 electron. Okay? I'm going to draw in yellow the covalent bond that's formed here and the covalent bond that's formed here. Okay? All right. I'm going to redraw this now to show the covalent bonds. Here is oxygen. There's hydrogen, and these are the lone pair electrons. And this is a molecule of water. Now, I want to show you that we have satisfied the octet rule here now. Okay? So I'm going to circle the octets in yellow here. I'm circling the octet around oxygen. Why is that an octet? Because this is 1, 2, 3, 4, 5, 6, 7, 8 electrons. All right. What about the octet around hydrogen? Well, remember, hydrogen can only hold 2 electrons, right? It's only got that 1 energy level, and that first energy level can only hold 2 electrons. So this is already maxed out. That hydrogen is maxed out by holding 2 electrons. And now hydrogen is stable, okay? All right, I'm going to draw a circle around that other octet. But for hydrogen, an octet means 2, all right? I hope that's not confusing, okay? So, really, in the end, let's be clear about this. Oh, I guess I can't erase that. I wanted to erase that. Just to show you, I'm just erasing. Okay. Sorry. Come on. There. Okay. Sorry that took so long. What you're seeing right here is the structure. Okay. The circles were only there that I was just counting an octet. This is an octet. That's 2 for hydrogen, that's an octet. That's 2 for hydrogen, that's an octet. But I really want to stress that this is the Lewis dot structure for water. Okay, so there it is. Let's try another one now. I want to show you something new in this next one. Okay. Okay, so here's carbon dioxide. And as I'm talking through this, all right, feel free, honestly, to stop the video every once in a while and write down some of the things that I'm saying, okay? Because I'm not going to write down everything on this video. I will tell you when I'm saying something important. And here comes something important. I want to talk to you guys about some rules of thumb that you can always follow with these when drawing out these Lewis dot structures. Here are some rules of thumb. Carbon, for one, is always going to have 4 bonds to it, okay? There's one exception that I can think of, and I'm not sure if it's ever going to come up in this class. I don't think it will, okay? So really, for carbon, always think 4 bonds, okay? For oxygen, oxygen is always going to have 2 bonds. Usually, it's going to have 2 bonds, okay? So just keep that in mind. Here's another thing to keep in mind. Carbon, when it's in a compound, it's usually going to be in the middle. It's going to be like the center atom in that compound. All right? All right, one other thing is that nature tends to like symmetry, and that is going to come up in this example. All right, so what I'm going to do now is start with the Lewis dot structures. I'll just write those down now. Okay, here's the Lewis dot structure for carbon. Okay, what I did here is I drew the Lewis dot structures for oxygen, both oxygens, and for carbon. Okay, it's important that when you're drawing these Lewis dot structures, that you're doubling up on the electrons here because these electrons are free, okay? They're free to form bonds. All right, you can see how I set this up symmetrically. I put carbon in the middle, I put oxygen on both sides. Okay, now here's our goal. We want to share electrons in order for every atom to end up with an octet. Okay, this is how we're going to do that. I am actually going to draw these covalent bonds in yellow. So I'm going to circle these 2 electrons. That's going to be a pair of shared electrons. And here is a shared pair of electrons. And, whoops, I should have done this a little bit differently. Okay, this is going to be a shared pair of electrons, and this is going to be a shared pair of electrons. Okay, all right, what have I just created here? Let's redraw this. And what I've created here are double bonds, okay? So carbon is going to be in the middle, and this is a double covalent bond. And a double covalent bond, okay? And what's left are these last pairs of electrons, okay? I drew 2 double covalent bonds. Each covalent bond represents 2 electrons. So this is 2, 4 electrons, 2, 4 electrons. If I watch the laser pointer, I'm just going to draw a circle around the octets. There's an octet. That's 8. And here's another octet. 2, 4, 6, 8. And 2, 4, 6, 8. Okay? We've satisfied the octet rule. We're trying to make octets around each atom to make it stable. What was new here is that in order to make that happen with this molecule, we needed 2 double bonds. All right, we're going to try one more, and yet another new thing is going to come at you. Okay, so this next one is hydrogen cyanide. You've probably heard of cyanide before. You know that it's a poison. Anyway, we'll never touch it in our class. All right, so here's the deal. We've got to draw a Lewis dot structure for this molecule. A couple things to keep in mind here. I said that when carbon is in a compound, it's usually going to be in the middle, okay? And nature tends to like symmetry. I guess there's going to be a semi-symmetry here. Anyhow, I'm going to start by just drawing out the Lewis dot structures. All right, so I just drew the Lewis dot structures. There's hydrogen. Here's carbon in the middle. Here's nitrogen, and I drew it this way on purpose so that things would line up in the way that I'd like them to. Notice that when we draw the Lewis dot structure for nitrogen, we have a pair of electrons here, all right? And that we have single electrons here. That's very important to see that, all right? Okay, in yellow then, again, like I did before, I am going to draw out or make a circle or an oval around the pairs of electrons that are going to be shared. Okay, here we go. There is a shared pair of electrons. There is a shared pair of electrons. There is a shared pair of electrons. And there is a shared pair of electrons. Okay, like I did before, I'm going to rewrite this, and I'm going to substitute lines for the pairs of electrons. All right, here we go. Carbon, line, 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 nitrogen with that lone pair of electrons, line, and hydrogen. Okay, and this is the structure for hydrogen cyanide. What's different here? Well, you can see I used a triple bond here, okay? I used the triple bond because this now gives me octets all the way around. So watch as I'm tracing this out, okay? This is a pair of electrons. This is a pair of electrons. This is a pair of electrons. Okay, around this nitrogen, I now have 2, 4, 6, 8 electrons. That is an octet around that nitrogen. Okay, what about around carbon? I have 2, 4, 6, 8 electrons around carbon. Awesome. We got that octet. And then remember, 2 electrons around hydrogen is a full outer layer. In other words, that's an octet. 2 is an octet for hydrogen. All right, another thing to think about, remember what I said about carbon usually having 4 bonding sites. Well, it does. It's always going to be for this class. Notice how I have 4 bonds here. That's 1, 2, 3, 4. Carbon always has 4 bonding sites around its around its atom, okay? So I think that this is probably getting you back up to speed after the last couple of days. We have a couple of worksheets. You definitely want to do the homework that is associated with Lewis dot structures. And just make sure that you understand how ions are formed, how ionic compounds are formed. That really takes care of the last 2 lectures that you missed if you were on retreat. All right, guys, see you in class.